calculate the volume of the solid obtained by rotating the region under y equals x squared about the x-axis for x between 0 and 2. So we begin by sketching the region described, which is going to be something that looks like this. Okay, remember, it's an x squared, so the graph will look something like this. And it's going to be between 0 and 2 on the x-axis. Okay, so this region right here will be rotated about the x-axis. So just imagine that this graph is floating, right? It's floating, and then you're rotating the region. And if you rotate the region, you're going to get something that looks like this. You rotate the region, then you're going to get something that looks like this, right? So you're going to get something that looks like that. Okay, that, right? So it's going to be like a cone, a little bit different than a cone though. Now, the only thing you need to know, you don't even need to know what it looks like. You just need to know what the region is before it is being rotated, because once it is rotated, they will be a solid, and these solids are made up of disks. Okay, so we first identify that this is rotation about the x-axis. It is perpendicular to the x-axis, so you would go cross section are disks. Okay, they're disks, and then the first thing you do is you find the area of a disk, or perhaps the area function. So disks are circles, so area is equal to pi r square. You can use let's use uppercase R because that's what I started with. So let's use uppercase R. So r square. R stands for your radius. Okay, so now to find R, you take the top curve minus the bottom curve. Your bottom curve happens to be the x-axis, so this is your bottom curve, so technically is equal to 0. Your top curve is the curve x squared, so technically it's x squared minus 0, which is just x squared. And so this line right here, guys, that would be like a typical disk, and that is the radius, which this radius is found by just figuring out this length, which is top curve minus the bottom curve, wherever those two endpoint touches. Okay, so we find out what R is, and we plug R in. We plug x squared in for R. So technically, the area function for a disk is pi. Remember R, put it in parentheses, so this is R, and then we square it, so that's the area of one disk. And so once we have found the area of one disk, we can now find the volume, which is setting up an integral throughout our domain, which is from 0 to 2, and then it's the area goes in here, and it's dx. And now notice that pi is a constant, so we can pull that to the front, and then that. So definitely you can write that as x to the 4th. So as you can see, we really don't need a calculator to finish this problem, so let's try to do it without a calculator. The antiderivative will be x to the 5 over 5. Evaluate that at 2, and that gives you 2 to the 5 over 5. And 2 to the 5 is going to be 32, so this is 32 over 5. And then f at 0 is 0, so technically the final answer is going to be 32 over 5 pi, and that is the total volume of this solid. Okay. Calculate the volume of the solid obtained by rotating the region y equals to x, y equal to 4 minus x about the x-axis. So now we get into the business of two curves. Okay, so here is the first curve, which is y equals to x. So y equals to x would look like this. Y equals to x, okay. And then, so this is y equals to x. And then the second curve is y equals to 4 minus x. So 4 stands for the y-intercept, 1, 2, 3, 4. And then the second one is actually negative x, which has a slope of 1. So then this is the second curve. This is y equal to negative x plus 4, or 4 minus x, same thing. When I write it like this, hopefully it's easier for you to see. So the region is rotated about the x-axis. So we're going to take this region and we're going to rotate this region about the x-axis. This region right here, bounded by this region right here, that region will be rotated about the x-axis, right? Because this region is bounded by the line y equals to x and about the line y equals to negative x plus 4. So then we have to be careful because we need to split this region up into two different integrals because there are two different functions for these disks. So for example, the first disk that's over here and there's another one over here, these are basically described by two different functions. So the first thing we need to do is we need to determine where these two functions intersect. So intersection y, so we have x equals to minus x plus 4.